Hello students. In the last video we have discussed about minimization of finite data. So in this video we'll discuss about grammar notations and its derivations. So the grammar was actually developed by Noam Chomsky. So he's a philosopher. And what is meant by a grammar? First of all, so grammar is a generative device so which is going to represent the languages. And every grammar is in the form of BNF, Backus Nar form. So what is a Backus Nar form denoting here? The left hand side always derives the right hand side. Remember this property. The left hand side always derives the right hand side. Means you cannot stop with the left hand side. Definitely you must go to the right hand side. Right. So there are so many types of grammars. Before going to that, as I told you, the grammars must be in the form of BNF. So this arrow is differentiating the left hand side and right hand side. And the basic definition of grammar is a set of rules, and the rules must be finite. The number of rules in the grammar must be finite, and this left hand side and right hand side can be anything. It can be one symbol or more number of symbols, right? And for every grammar there must be a symbol called starting or initial. So in the grammar, they'll mention you what is a starting symbol. Otherwise, you can take the first production, the left hand side symbol as a starting symbol. Then we are going to have the terms like non-terminals and terminals. We'll discuss about that later. And coming to this, let me take a simple example here. This arrow is separating the sides, left hand side and right hand side. And coming to this, whatever is occurred on left hand side, in this case, should be treated as non-terminals because they are not terminating here, they are giving something else on right hand side. So S, A, B, C are the non-terminals and small a, small b are the terminals here in this case. But actually, if you are given a grammar, how to identify the non-terminals and terminal, that we'll discuss later, right? And see, as I told you, the grammar must be in the form of BNF, left hand side and right hand side. So this arrow is separating the left hand side and right hand side as we have discussed earlier, right? So then we can take anything on left hand side and we can take anything on the right hand side. There is no restriction. But if you keep some restrictions on left hand side and if you keep some restrictions on right hand side, based on the restrictions or the conditions, we can divide the grammars into mainly four types. Those are type 0, type 1, type 2 and type 3 grammars. So type 0 grammars is also called as unrestricted grammar. So there are no restrictions in it. Of course, in the 5th unit, we'll discuss more about these unrestricted grammars. And type 1 grammars are going to have anything on left hand side and right hand side. But the rule is the left hand side, length of the left hand side must be less than or equivalent to length of the right hand side. You can take anything on left hand side, you can take anything on the right hand side. But the length, if you take it, so the length of the left hand side should be less than or equivalent to length of the right hand side. So you can take like this, but you cannot take in this way. See, B tends to alpha B. Here we are having left hand side 3 symbols, right hand side only 2 symbols. So that is not allowed in the type 1 grammars. And this is also called as context sensitive grammars. And of course, at least we should have one non-terminal on the left hand side, right? At least one non-terminal. You cannot take only the terminals. Then coming to the type 2 grammars, of course, we'll discuss each and every grammar individually in the hierarchy with the rules, right? So just I'm giving you the definition only here, but what are the rules? Everything we'll discuss. And type 2 grammars are also called as context-free grammars. These are the most widely used grammars. And the left hand side, we should have only one non-terminal. Here we can take anything. Here we can take anything, no restrictions at all. But in this type 2 grammar, the left hand side must be only one non-terminal and right hand side can be anything. You can take whatever you want. Right? Sometimes even it can be empty also. And means you can take an epsilon production also. And type 3 grammars. So they are also called as regular grammars. and they must be, the left hand side must be only one non-terminal, and right hand side you may have a terminal followed by a non-terminal or a single terminal, or sometimes you may have a non-terminal followed by a terminal also, right? So anything is not allowed here. Only two symbols, and one of the symbol must be a terminal. Of course, sometimes you can even take the epsilon also. So as I told you, we'll discuss more about all the remaining grammars in the fifth unit. But coming to this second unit, we'll mainly concentrating on the context-free grammars. So first, before going to the example, let me tell you what are the rules of context-free grammar. So it's also called as type 2 grammar, right? So type 2 grammar. What does it mean? See, every production must be in the form of alpha tends to beta. So here the arrow is separating the sides. Then if you want to say that a grammar is context-free grammar, what are the rules? We have two rules. The first and the foremost rule is the left hand side only one symbol is allowed, and that too a non-terminal is allowed, left hand side, right? And right hand side can be anything. You can take whatever you want with the non-terminals and terminals. We have discussed about the regular expression in the last chapter. You can take whatever you want. Sometimes even you can take the epsilon, means any number of terminals, any number of non-terminals, combination of terminals and non-terminals, right? Sometimes even you can take an epsilon also. These are the two rules to tell that the grammar is context-free grammars. And see, every grammar is denoted with the four tuples VTPS, or sometimes we can call it as NTPS. V is set of variables, T means set of terminals, P means set of productions or rules must be finite, and S is the starting symbol of the grammar. So in the grammar you will be given a symbol as starting symbol, otherwise you can take the first production left hand side non-terminal as a starting symbol. Now, if you are given a grammar like this, then how to identify the non-terminals and terminals. So, see, according to the rule of context-free grammar, left-hand side only one non-terminal is allowed. So, irrespective of its case, whether it is a capital letter or small letter, if something is occurred, left-hand side should be considered as a non-terminal. So, what you are having here is A, B, C. Those are non-terminals or variables. See guys, for example, by mistake if I have given like this and you are saying that this is a context-free grammar and the non-terminals must be here small a and terminal is capital A. So there is no restriction rule that only capital letters are non-terminals or small letters are terminals. If something is occurred left hand side, that must be treated as a non-terminal in the case of context-free grammars. Then excluding all these non-terminals, whatever is occurred on right hand side should be treated as terminals A and B, and whatever the P means productions. What are the productions we are having? S tends to A, B, like we are having four productions. And what is the starting symbol? S is the starting symbol. But then how we can write our grammars? Say, for example, we can start like this. S tends to A. So the language generated by this A. For example, if your regular expression is A plus B and you have to take A or B, how to write the grammar for it? Simply you can write S tends to either A or B. That's it. For example, you have to take AB, right? The string we are going to generate is AB. Then how to write it? So you can take like this. S tends to AB. That's it. So for example, if your regular expression is A star, what it is going to generate epsilon, A, so on. See guys, same like finite data. If your language is having infinite number, but you have to represent in a finite, you have to identify something which is recursively occurring. So what is recursively occurring here? A. Then you can take it S tends to A. This A has to be taken recursively. Then you can write AS. AS. So that you can take any number of A's. And we must have a termination condition. That's the reason we can take epsilon. Right? So this is a grammar for A star or A power N. For example, if you are asked to take A plus B whole star, you can take anything with the A comma B. Then you can write any number of A's or any number of B's, and combination you can take A followed by B, B followed by S. Then you can go with the epsilon. Like that you can write your own grammars. Now let me go with the a power n, b power n. So how to write the grammar for it? See, the language is epsilon ab, right? AABB, AAABBB, the number of a's followed by equal number of b's. So you have to identify the recursive term. First epsilon, then AB. How to get the double A double B? In between AB, you have to substitute one more AB. Then you can write AABB. How to get the triple A triple B? In between this, you can write again AB. So we have already two A's. In between the AB, you can substitute AB. Then already we are having BB like this. So then what will be happen here? S tends to the minimum string is A and B. So S is AB. In between AB, again you have to substitute the AB. Like substitute any number of times, then it will give you number of A's followed by equal number of B's. And of course, we must have a termination condition. So this is how you have to write your own grammars. But in exam, you never be asked to write the grammars, but you should have some idea, right? And every grammar generates a language. So how to go with that language? Then we'll be having the derivations. Okay. So we are having one-step derivation, two-step derivation like that. What does it mean by derivation? For example, if I'm having a production like this, A alpha beta, right, and derive. So double lined arrow is defining the derivation. Then we can replace like this: A, B, beta, if and only if we have a production like alpha tends to beta, right? Means left hand side we have like this: A alpha beta. Then if the alpha is having a production like alpha tends to beta, then we can derive this A, B, beta after substituting the production alpha tends to B. This is called derivation, right? So here alpha might be having some productions, anything, we have to substitute one. For example, here see, A alpha A beta tends to A Y beta. What is the difference here? A is replaced with the gamma. So what could be the production we might have used here? The A might be having a production like A tends to gamma. That's the reason we have replaced this A with the gamma. That's how we got it, right? So now you may have the two-step derivation. For example, alpha A beta is deriving alpha AB beta after two productions. What could be the productions you might be having here? See, A might be having AB and B might be having B. So you can take like this: alpha A beta. First we are substituting this AB. So alpha AB beta. Then next AB beta, sorry, we are substituting it. In the second step, the B is replaced with the B. So alpha AB beta. So this is two-step derivation. Like that we are going to have n-step derivations also. And we are having two kinds of derivations here: leftmost derivation and rightmost derivation. What does it mean? See, let me go with this. First, we'll start with the grammar here. The non-terminals and E and I. Terminals are A, B, 0, 1. Okay. And starting symbol is E. So the derivation you can start from here. See, E tends to, we can take it A plus A. Then let me go with E plus E. You can substitute E plus E. What is the production we have used here? E tends to E plus E. Okay. Then we are having two non-terminals. So in every step, if you substitute the leftmost non-terminal, that is called leftmost derivation. So now I'll replace this E with the I plus E. How we got it? E tends to I. We have used the production. E tends to I. Then let me go with this. Leftmost non-terminal is I. Then you can go with I tends to A plus E. So I got I tends to A. So now we are having only one non-terminal. Then you can go with this. That is the leftmost. I can go with E star E. Then we have substituted E tends to E star E. And here this is the leftmost non-terminal. Then you can go with A plus I star E. So what is the production we have used here? E tends to I. Same way A plus A star E. Then we got I tends to A. Same way you can substitute A plus A star I and A plus A star A. We got it. So in each and every step we have replaced the leftmost non-terminal. That's why it is leftmost derivation. Same way rightmost derivation means we have to replace rightmost non-terminal. We'll discuss in the next video.